Alright guys, today we're going to be doing the partial fraction decomposition of this fraction. So, let's get started. Alright, so step one is going to be splitting this into two different fractions, because as we can see we have two irreducible quadratics right here. So what that's going to mean is we're not going to be able to factor those anymore. So we already know that we have two fractions. And since these are quadratic, we're going to have two linear factors, which means four variables that we're going to have to solve for. Alright, so we can start off. We know that this is going to be some variable a plus b. This is going to be, of course, linear because this is quadratic. And then we can put it over this, x squared minus 4x plus 5, just like that. And then we're also going to have to add some term cx plus d, just like this. And then, of course, the other quadratic. So there we go. Alright, you can barely see that, so let's see. Alright, so now what we're going to do is we're going to multiply both sides by this denominator, and we're going to cancel a bunch of these terms. So, number one, we know that when we multiply this by these two, these are the same, so they're going to cancel, which only leaves this one, so let's just write the left side first. Minus 13, alright, is equal to, of course, plus b multiplied by this, and obviously those cancel, as I said, so now we're going to get x squared plus 3x plus 4. And we're also going to have to add the cx plus d term multiplied by x squared minus 4x plus 5, as this term's going to cancel on both sides. Alright, so now that we have this, we can set up a system of equations. So the immediate way that I can think of this is, so we need to solve for a, b, c, and d. So what we can do is we can plug in 0 for the x, and then what we can get is we're only going to get b and d, and this is just going to give us a little shortcut. But that seems about good. Seems right. Alright. So now if we plug in 0, 0, 0, all three of these cancel. This is just negative 13. The negative 13 is going to be equal to, this is going to cancel, leaving us to just b. This and this are going to cancel. So it's going to be 4b, just like that, plus, this is going to cancel, these two are going to cancel, plus 5d. So now that's our first equation. Actually going to just rearrange that real fast. Equals negative 13, just like that. And there we go. Alright. Now I think we should probably expand the rest of these, so yeah, that's probably the best plan. So I'm going to bring out the red marker. Let's see. So, alright, so we know that this is going to become ax cubed. I'm actually going to, these are going to be on the cubic, quadratic, and so on. So, plus, this is going to make a lot more sense soon, ax squared, 3x squared actually, plus 5d. Alright. Now, what we know is that from over here, this is the cubic term, which means a and c both need to add up to 9, so we can generate a system of equations based on this for the x squared, the x, and the coefficient terms, so we know all that. So, let me move back to my other marker here. So now we know that, let's see, so 3a, actually I'll write this down here. So, d, so we know that all of these are going to have to equal negative 24. Then we know that it's negative 4c, this is kind of backwards, b, 3a. So all of these are going to have to add. So now we know that all of these are going to have to add to negative 24 to get this coefficient for the quadratic term. And now we're going to have, yep, 4a plus 3b plus c has to be equal to 9. Very nice. Yeah, this is looking very good. Alright. So now that we know that, this is a system, so we're going to write our curly brace. So now we know that this is a system of 4 variables and 4 equations that we're going to have to solve. So this means, yeah, we can use Gaussian elimination, I suppose. Let me get out the blue marker. Alright, so we can use Gaussian elimination. This is going to be very fun. So it's a 4x4 matrix because we have 4 variables. This is going to be very interesting. So we have the first matrix, so A is equal to 0. 0. B is 4. 5, 0, 5. Alright, so now we set up our matrix. Alright, so I've erased the whole board, and this is to give us some more space, as we are definitely going to need some space. And let's switch back to our red marker. This is going to contrast a lot better. Alright, so the first elementary operation that I want to do is our row swap, because as you can see, alright, so what we want in the end is we want 1, 1, 1, 1, and then we just want zeros for these, for this like diagonal section, and then zeros for this diagonal section. And what this is going to give us is this is literally going to allow us to solve every single, this is just going to allow us to solve for every single variable just by converting it back into a system of equations. There we go. Alright, so the first row operation that I want to do is going to be a swap. We're going to swap rows 1 and 2. Alright, let me look at my notes. So we should end up getting 3, 1, negative 4, 1. Alright, that one's pretty simple, but it gets a lot harder. So now, what we want to do, so we can just divide by 3 or multiply by 1/3. Alright, so what this should give us is this. So 1/3, 9. Alright, pretty good. Good so far. Well, let's just clear this up. Alright. Alright, so what we're going to do is we're going to do this minus 4 times this, and we're just going to put it in there. And that's going to be our first compound operation. And then our second compound operation is we're just going to do this minus this and put it into this row. So, yeah, we're just going to take R4 and we're going to subtract R1 from it as our second operation. So this is like a compound one, it'll just save me some space. Alright, so this is what we're going to get after doing those elementary operations. As you can see, we've already eliminated 3 of these, pretty good. And we already technically have this one eliminated, which is very nice. So now, our next step is going to take this row and divide it by 4. Alright, so I'm just going to move this down here. So we get 1, 1/3, negative 4/3. Alright, so this is what it should look like afterwards. So we have a big 0 here, 0, 0, 0. Nothing else eliminated, but now we have a 1 in this row. Pretty good. So number 1, we're going to take row 1, and we're going to subtract R2. We're just going to take this, we're going to subtract R2 over 3. Then, what we're going to do, after we've done that, is we're going to take R3, and we're going to subtract 5/3 times R2. Alright, and then the last one, probably the simplest one because it's just an addition, we're going to do R4 plus 1/3 times R2. And this is going to simplify a lot of things. Alright, so now what we want to do, after you've done all those operations, you should get... Alright, now this is what you should be getting. After you do all of those operations, as you can see, quite a bit of zeros. Alright, now our next operation is to be multiplying row 3 by 3 over 31. This is going to cancel that and make that a... That's going to make that a 1. As you can see, a lot of fractions. We have one more compound operation, which is we're going to take R1 and we're going to add 4/3 times R3. Yeah. This is going to cancel this negative 4/3 to make it a 0. All right, let's write that down. All right, so that's what we get from our first compound operation. Negative 129 over 124 and 893 over 124. And then after that, what we want to do is we want to fill in these two rows. Those we're not doing anything with those. All right, and then, oops, let's see. Can we get this to focus? All right, so now we have those two filled in. Those are the same as the last time. And then our second operation is going to be taking R4 and subtracting 7/3 times R3. And this is, I'm going to eliminate this one. This 7/3 right here. All right, let's do that one. All right. So then we get 109 over 62 and negative 545 over 62. And of course these are zeros, and now what we can do is we can do a very simple one, is we can just multiply by 62 over 109 and we get a 0 there, or sorry, a 1 there. And that's very nice, and in fact it's going to cancel some of this. It's going to look very nice. Alright, so after this one, as you may be able to see, we simply just get 1 here and a negative 5 over there. So as you can see, we're already starting to simplify this, and we know now, since this is the D column, we know that D is equal to negative 5, which is already like the first step in our answer, which is very nice. Now we have quite a large and seemingly unnecessarily complicated step, but it's just a bunch of large mixed fractions that we need to be multiplying and dividing by in order to just get the rest of these done, or zeros. So I'm just gonna actually here we can write, this is actually our final step, so I'm gonna write this last matrix in blue. It's gonna look very nice actually. Let's see. So our first step, alright, so our first step is to do R1 minus, our first step is to do R1 plus 124 over 129 times R4. This is going to cancel this and make it a 0, and it's also going to simplify this quite a bit, and you're going to see that it really is simplifying. Alright, so now we get 1, 0, 0, 0, and then our final number is 2. That's it. Look at that. Alright, for our next row, we're actually going to take this, we're going to subtract 5/4 times this. And once again, that's just going to cancel this column. Alright, so once we do that, we'll get 1, 0, 1, 0, 0, and then this is simply going to be 3. Wow, would you look at that? That is very nice. Alright, and then our next one is 0, 0, 1, 0. I'm sorry, this looks like it's 0, 0. But it's just 0 and 0. 0, 0, 1, 0. And we, as you might have guessed, we're just going to multiply this by 89 over 124, and then we're going to add it to this. And when we do that, we're simply just going to get 7. Look at that, that's already canceling. And then, what we're going to do is we're just going to rewrite this one, as we're not doing an operation, we already have this. And now we actually have the solution to our original question. Yeah, it seems like it would be all about matrices at this point. I mean, it kind of was, but what we originally wanted to do was we really just wanted to decompose this fraction, this original fraction into this, and now we can do that. So, and now I'm actually going to erase all of this, and I think it'll look very nice. Alright, we've gotten rid of all of the pain that we just had, and now we can just finally write down this answer. This is gonna look really nice. Alright, so we now, the solution, we know A was 2, so 2x plus, what was B? Well, B was 3. So now we have 3 over
4x plus 5 plus, and then what was c? C was 7. So we have 7x. D was negative 5. Just like that. Let's expand that. X squared plus 3x plus 4. Box that, and we're done. That's how we do the partial fraction decomposition. And wow, this one took a long time, as we had these two quadratics that were irreducible, which really sucked. But I think this is a pretty nice result, to be honest. Alright guys, I thought that was pretty cool. I just wanted to show how to do a partial fraction decomposition. Alright, I'll see you.